Good morning, sir. Welcome you all for the fourth day of AICT Training and Learning sponsored Faculty Development Program on Sensor Technology. It's my immense pleasure to introduce today's resource person, Dr. M.Sundaram, sir, Associate Professor, PhD College of Technology, Coimbatore. Dr. M.Sundaram completed his ME in Electrical Machines from PSG College of Technology, Coimbatore, and did his PhD on Electrical Machine Design from Anna University, Chennai. He has 6 years of industrial experience in the field of CNC and electrical maintenance and has 21 years of teaching experience in electrical machines, design of special machines, CNC, industrial automation, and power electronics and drives. Currently, he is a program coordinator for ME Electrical Machines in the Department of Electrical and Electronics Engineering at PSG College of Technology, Coimbatore. His area of research includes electrical machines, robotics and automation, power electronics and drives, and industrial automation. He has successfully carried out several sponsored research work for research establishment like DST, NIOT, IGCR, and high-tech. Currently, he has 10 sponsored projects from various organizations in the worth of 15 crores. He established 3 Centers of Excellence at PSG College of Technology. He has also done consultancy work for several industries in India. He has published 11 papers in various international journals and conferences. He is a member of the Convener Committee, SITAR, Coimbatore. Now we invite Dr. M.Sundaram, sir, to share his research ideas in the field of smart sensor for automation and industrial technology. Welcome you, sir.
Good morning.
Sir, your voice is breaking, sir.
Hello.
Sir?
Are you okay, madam, now?
Yes, sir. Now it's okay, sir.
Okay. So, good morning to all. This is Sundaram from PSG. I thank my colleagues for contributing to my biodata, whatever that given in the introduction. It is a teamwork. Thanks to my all colleagues. Now, in this session, 2-hour session, we are going to discuss about the industrial automation sensor and healthcare sensor. What is in industrial trend or in practical usage? And from the basics, then we will slowly
enter. Excuse me, sir.
Yes, madam.
Sorry for the interruption. Sir, I gave a present screen, share screen. Sir.
Okay. Yes.
Thank you, sir.
Right. So, you see this screen?
Yes, sir.
Okay. Thank you.
Thank you, sir.
So we will discuss about industrial automation and healthcare sensors one by one. First, we will start with why we should think on this, or when we deliver something to the students after this FDP, how to equip them to meet the industry. Something more than that. So always I learn from my seniors within a double code. Learn how to learn. Learning is a continual process. We know that. So how to nurturize in our students to improve this learning process? That's possible by creating some good environment and some motivation. If you look, why do we need this subject? Because nowadays, every student's asking why I should study this subject. What is the benefit for me? Am I going to get some opportunity in this area or in this allied area with respect to my knowledge? If yes, then what are the skill set that I should improve apart from my BE or ME course? Engineers need not to be a graduates, right? So engineering basically common sense. Anybody can become a good engineer, whether he graduated or not, or he may be diploma, or sometimes a BSc physics, they're going to be a good engineer. So engineering is not by graduation, it's by experience and by doing something. That's the outcome-based education. So we want to tell to them that if you see the global industrial market for the sensor at a CAGR of acceleration around 9%, it is a good percentage. And growth contributed by ASEAN Pacific countries and by other things you can see here, it's around 45%. Of course, the year of 21, we know that due to COVID, there is a dip, but the projection is very high. Yes, there is a scope available, right? Then there are some top 10 global manufacturers who are doing a very good sensors, extremely good. The industry is looking. So we have to provide those companies list because this company list will give some information to our students. So we can ask them to go for assignment, preparation of some specification, reading of some specification, latest technology, what concepts they are using. So our role is how the fundamentals can be linked to those higher-end or high-end technology sensors. So if you see on the other side, so many sensor companies, like there are companies like SIG, Omron, they are using sensors everywhere. But there are some high-end sensor companies like First Sensor, even Honeywell, they are doing great number of sensors things. So this is about the company. Next, if you come, in all the sensors, the sensor may be a very latest one, or we are looking the sensor in next 5 years. But if you look the basic behind that, all fundamental laws like Ampere's law, Curie's law, Faraday's law, photoconductive effect. So these are the fundamentals. If we strong understanding in these fundamentals, definitely whatever may be the sensors that is upcoming or in industry use today will always match to this. So this is about how the sensors are made. Every sensors are made from this fundamental law. Reason sometimes our students are thinking that I already did this law code about laws and other fundamentals in my CBSE 8th standard, 9th standard. Why I should repeat this? It's getting boring. Even I could learn from yesterday's news that data science is going to be added in the upcoming CBSE syllabus. It means that immediately after school he is eligible for do engineering. Engineering. It's not like that. Yes, he might study it, I agree, but how to apply that? So that's the most important. So again, we have to stress them, insist them that these laws are still available. It's most important to understand in 360 degree. Why? This understanding in 360 degree is important because when you select a sensor, you have to consider so many factors. Otherwise, paper rose will not give any smell like real rose. So if you want to get some real taste of engineering, then he should know how to link these fundamentals in your sensor with environmental factors, economic factors, and sensor characteristics. So when we want to select one sensor for a given application, it may be industry or healthcare. If you look at environmental factors, temperature, humidity, corrosion, size, overrange protection, susceptibility, ruggedness, power consumption, and self-test capability. Even if you take any one case, say for example, power consumption. Nowadays we are using oxiometer, right? Everybody's almost more than 30% of home nowadays having this oximeter. Everyone during this COVID period, they want to check. So this power consumption of that individual device should be very, very minimum. Not only that, the operating bandwidth voltage of that particular device with the same precision, accuracy, resolution, it should be maintained. So I am using 1.5 volt cell, for example, right? So it should work from 1.1 to 1.6 without much deviation. The error should be very, very minimal. So how to design a sensoric circuit to meet this condition? One example, kerosene. See, you are going to use kerosene applications like underwater vehicle or sometimes petrochemical industries. How the sensors can be protected from corrosion and also cost, and it should be available wherever you go. It should compatible to all the circuit, and your lifetime is also most important. Next one, if you see that characteristic, before selecting or studying any sensor, we should understand about this sensor characteristic very much well. So like sensitivity, range, stability, repeatability, linearity, error, response time, and frequency response. So these terminologies are most important when you go for industry or particularly in healthcare or anywhere else. Then how we are going to select factors that will decide means first one is sensing object. What object you are going to sense? Its size, material, shape, surface conditions, whether it is a color or reflectiveness or unevenness. Then bouncing. Sometimes our object may be bouncing while it passing through the process, but still we want to measure it, sense it. Then some kind of variation in that. Then how fast it moves. Automated industries, in packing industries, it moves very fast. So how we are going to sense what would be the sensing speed, whether it is going to be a single or continuous. Similarly, some special sensing objects like wafer in semiconductor industry, solar panel manufacturing, wafer, glass substrate, register mark, different type of markings, right? Transparent, whether it's going to be a liquid or liquid leak detection, liquid level detection, whether it may be a hot melt glue or it may be a gas. If it is a gas, what kind of gas? And sometimes it's need to be measured in human body. Similarly, for what purpose we are going to use, whether it is general purpose like absence or present that equipment, or are we going to pass in quality control, or we are going to drop it, or it is being used for positioning to do some operation, and it's to detect a color, exact color detection, particularly in lot of biomedical applications, petrochemical industries, fertilizers, textile machines. So this color detection is so much important. Then shape detection, uniformity. So even in pharmaceutical industries, shape detection is most important. Out of automobile industries in mass production. And it's not overlapping of two objects. Is there any overlapping or rendering? And sometimes it must be used for displacement measurement, not only for absence, but also to measure the displacement. That means it is an analog. Eccentricity, seams, liquid level, or sometimes pick and place, or sometimes like entry detection. Or even nowadays, if you look at Singapore, most of the robots are doing the scanning of COVID patients in China and Singapore, Taiwan, US. If you look this sensitivity, it is basically a slope of the output characteristic. That means a minimum input of physical parameter that will create a detectable output change. For example, I am moving a 0.1 mm. If the 0.1 mm displacement, if it is capable of giving a small delta change in output, that is the sensitivity. Range any sensor, what is the minimum and maximum? If it is a pressure, what should be the minimum bar and what should be whether it is a 0 or minus 100 to plus 100, what is the range? Precision. It is actually this precision is your reproducibility degree of reproducibility of measurement. How much times the same value will be repeated for measuring the same quantity. That is called your precision. Then if you take resolution, so the smallest detectable change in our input parameter, particularly in biotech processing industries, even you could notice some, I think 1 or 2 years back, Nestle, noodles, packet, everything is being not approved only because of some 0.4 to 0.5% lead content more in that product. So that 0.2, 0.3% more, it is by sensor issues or some program issues or some conceptual itself. But this resolution is most important when we go for such kind of measurement. Then if you see the accuracy of the sensor, basically it is between actual value and the indicated value of the output sensor. Say they are giving, it is giving so much kilogram or so much milligram, whether it is coming same value or it has any error. So these are some of the important characteristics that we have to understand before getting into the sensor. The next, if you see the classification of sensors, there are two types of sensors basically available. One is the active and another is passive. So active means from the picture itself you can understand there is no need of power supply to the sensor. It is kind of transducer like thermocouple. So if the physical quantity appear on this here for easy understanding on candle with the light for giving a temperature. So in this case, there is no need of any supply for this sensor to give output. But in passive, yes, you have to give an auxiliary supply. This is most important. Because sometimes we cannot give a supply. If you take healthcare, pacemaker and some more thing, some sensors which we would like to embed inside our body. So by the time we should not think about supplying or replacement of cell, battery, those things. If it is external, yes, you can done easily. But for internal, you can't do that. So we have to think, my selection should be on passive or active. This is one thing. Then classification is again according to whether it is a digital or it is analog. See, one thing, nowadays we are going digital everywhere, right? Digital economy, digital processing, the entire world is digital. But we should understand one thing. By nature, everything is in analog quantity. That means what? Physical available is analog. What you want to produce, that should be analog. But only thing, processing should be digital. That's why we are looking for solution, accuracy, fast, speed, whatever it is, quality. That means analog will be available. We have to convert that analog to digital. Then again, you have to process in analog. That means you have to give analog output. So both input and output usage wise, it is analog. But process is by digital. But some places we have to use digital like this, some kind of pulse producing. So output will be a pulse nature. This pulse on off. So it is a discrete signal. So this discrete signal will be counted by using an electronic counter. It may be an analog circuit or it may be again digital circuit. Sometimes, so definitely for processing industries, processing quantities, we should go for analog, like thermocouple. So where you will get a variable voltage. Then that voltage should be signal conditioned by our system. That means instrumentation amplifier. Sometimes you will get only millivolt or milliampere. So that millivolt and milliampere should be amplified by using our amplifier circuit by analog or digital. Then that should be given as analog output signal like this. So any type, it may be a digital or analog, you can see input like pressure, temperature, flow, level. These are some of the examples. But the sensor will give for the measured physical quantity as a electrical output. So that electrical output probably between 0 to 10 volt. It is a standard. But small changes according to the rare usage, it may be a -10 to ±10 maximum. If you use the industrial controller, then we will go up to 10 volt. But embedded controller like microcontroller processor will go up to 5 volt. Similarly, current output, mostly it is 4 to 20 milliampere. And there is a big question we can ask, why is 0 in voltage case, why not 0 in ampere case? These things we will see later. But we can ask the students to think about fundamentals. Because Ohm's law is playing an important role at this point. Ohm's law, just Ohm's law. But this current output sensors are not available in very old days. Probably it is very familiar in this decade, 10 years before, after. But before 10 years, current sensors are very mild, few numbers. Now only everywhere people want to use current outputs. Then sometimes the resistance, it may be PTC or NTC. Mostly NTC are used. The reason is, whenever the operating temperature increase, the negative temperature means the resistance will decrease. So when the temperature increase, resistance will decrease, so that the drop across that shunt will decrease. So that voltage only we are giving to our microcontroller. So it will not go beyond the operating voltage. That is the purpose why it is coming. So it will be always in negative in terms of positive. So this is also a kind of Ohm's law, right? So this is one kind. The next, while we select a sensor, standards are most important, because we got a feedback from the industries. Yes, our students are good in programming and quick learning, everything, but they are very much lack with respect to industry standards what they are using. A selection of those important sensors or some sensor instruments is most important with respect to standards category, or we will call this as a utilization category. Like AC1, AC2, AC3, AC4, and AC15. These are some of the categories clarified under International Electric Techno Commission. Loading nature, it may be a pure resistive, or it may be slightly inductive, or it may be capacitive, or it may be inductive. Because each load will behave differently. If you take R load, L load, C load, the current and its associated voltage waveforms are not going to be unique. It is going to be varying. So according to this nature, we have to sense the circuit, we have to design the sensors, we have to design the sensor control circuits. There are several categories to avoid the failures, because suppose if I am connecting one sensor in my solenoid circuit, solenoid is basically inductive in nature. So whenever I turn on and turn off, because of the inductive nature, there may be some switching transients. Similarly, if I use capacitors, if I use the transformer, incandescent, electric discharge valve. So these are all some important utilization category when we go to biomedical applications, healthcare, and not only healthcare, also in industry. Most of the time you might hear, wherever there is a fire accident, simply people will put this fire accident is because of leakage of electricity. What do you mean by leakage of electricity? Is it going to leak out and creating some? No, definitely not. See, every device, every sensor has its own temperature limitations. When a temperature goes beyond certain limit, then the fire accident will occur. So that small fire spot will lead to a big accident. That's what's happening in our mobile phone. A small pressure because of the heat applied on the lithium-ion battery create a puncture. So that small puncture with the high temperature, high pressure, compressed agents inside the battery creates a fire. Once it's done, then all other devices, PCBs surrounding that spark of fire will accelerate because everything is made up of collagen content. So easily it will get melt and it will accelerate. So we have to look all these category like AC1 to AC3, what kind of loads we are going to use. Accordingly, we have to use sensor. Similarly, DC. See, most of the solar DC renewable energy in industries, it is a power generating industry nowadays, right? Because if you look in the last 4-5 years, central government is very aggressive in generating more renewable energy. Almost 1 gigawatt we reach now, 1 gigawatt. 1/3 of power we are looking now from renewable energy. So there, if most of the places, even I could see in our places, MCB, circuit breakers, what they are using is not for DC, it is AC. So AC circuit breakers should not be used for DC. It will work, but the problem is it doesn't have a protection for fire. When an arc occurs inside opening the circuit, that arc may lead to failure of that device. So that is most important. So this is so far what we discussed is about sensors basics. Starting from what is sensor, what is the market, what are the companies are manufacturing, what are the types, classifications, what are the specifications that we have to look, terminologies, those things we discuss. First, this is important before getting into it. People are nowadays talking about different sensors for different applications. Basically, where it comes, it's basically comes from a human being. Just to take our tongue, not only for speech, not only for taste, composition of taste. See, whether it is sour or sweet or bitter, whatever it is, composition, what a composition. It is highly imaginable. Can we do any sensor like tongue? Yes, a lot of people are working, even our students in Purdue and MIT is working with the professors to create a sensor like kind of tongue. It's an amazing one. It is a nature. So how to evolve is biomimicries, right? Wherever you go there, whether we are looking for some animals or for some trees, plants, or some insects, or some human beings. So the natural product by God or by nature. Those things we have to always consider when selecting or using. Even if you want to make some speaker, microphones. Now microphones are coming up in different ways now in digital world. So how to look on that? That's your ear and drum and its material and its lot of engineering characteristic attributes. So we have to keep on thinking like that. That's why in new education policy, even though it is engineering, biology is going to be a part of that. So it is a kindling of that mind. See, the report says always we people are working for NIRF. It is very, very unfortunate. I am not saying that NIRF is not necessary, but the orientation regarding NIRF ranking. We are not a paper making machines, but unfortunately, the documentation is being given more important in the education system rather than how to make our students to think from the nature. So that's why new education policy, something like zoology is being added, same in biology. So if you learn it works, you take a lizard, right? Lizard is such a wonderful sensoric mechanism, right? Mosquito you take, what a high sensible mechanism in a mosquito. Mosquito is flipping its around 1 lakh times in a second. And how it escapes in rain. Could you notice rain drops? For every raindrop, it will skip and it will go. How fast it could detect. So that's the engineering. So those sensors can be easily understood, operation-wise, characteristic-wise, design-wise. Now people are talking about means somebody may be working for their PhD R&D purpose for sensors, sensor fusion. So whether it's MEMS or nano, where it comes from our natural body or from natural plants and animals. So these things we have to keep it in mind when we want to talk about sensor, right? So this is about the first part. Now I would like to go for the second one, that is the basic switches. Could you see this? I'm changing the PPT 1 to 2 now. Just anyone can respond. I could see this. Or you can chat me. Maybe I think attendees mic audio is muted. Okay, thank you. Thanks to Dr. Lauraj. I think Sir responded, and also Anupam. Thank you. So first we will go with the digital. As I told, we have a digital and analog. First we have a limit switch. Yes. Suppose you take limit switch. This is a limit switch. It is easy to understand the operation if it is a video or animation. Not only that, there is a specification in this. We should tell to the students how to read this specification, what is the important in this. Here you can see AC 15, DC 13. So these are the utilization categories. So when he select a limit switch or when he see a limit switch, he should aware about this utilization category. So can I use this limit switch in my industrial automation, inductive load or resistive load or motor load, or even if you go to biomedical industries, CT scan machine, where it is being used in moving mechanism, those things. And also these materials, right? So this is one kind of limit switch. When he press, the moving plunger moves internally and it will open it. So this is some kind of spec like this voltage. And you can see this ingress protection category, IP40, we will see later. And there are two current ratings with respect to AC 15 category and DC 13 category. See, this is most important. Sometimes if you look, this limit switch is capable to operate at 1.5 ampere. Suppose same thing if you use in DC 13 category, then its operating current is several times, only 0.3 ampere. So if we fail to select properly, then it will lead to matched accident, right? And also some contacts that we will see later on. So here you can see that it is a internal, there is a two connection. Here you have two connections and you can check with the multimeter where are the normally open and normally closed contacts. Normally open means without any pressing, that contact will be open condition. Say this is a normally open, there is no close. But whenever he press, that normally open is closed, not NC. Normally open, normally closed. That is as it is. Here you can see normally closed. It is permanently closed now when it is not pressed. But when you press, the contact will get open. So NC will go to open, NO will go to close. So that is about the basic of limit switches. Then if you see that, you can see several variety of limit switches. It depends upon the application where you are going to use, in which place it is going to use. Accordingly, the levers mechanism, what you are seeing here, is going to change. So this is also most important. You can see, look here, and according to the IP category, moving category, some are with the roller, some are with adjustable roller, some are with the plunger mechanism like this, like this. So these are the different variety of limit switches available with a different utilization category. Right now, let us will go to arrow. Yes. there are different materials are being used. You can see for contact, gold, silver alloy, platinum, silver, palladium. These are the different material. Each has its own characteristic. Depends upon the standard. Particularly when you are making a biomedical machines or some robots or some automatic machines, where it is going to use, in which application, which environment, that environment decides the type of material. Similarly, on movable springs. So both contact springs are made up of different material for different characteristic. So I'm not able to read all those things due to time availability, but just I want to indicate, tell to you friends that these are the classifications available. Even we can tell this information to the student. So by keeping this information in their mind, when they go for selection, by the time, yes, we have to look on the material by which these parts are being made in order to avoid the failure of the rating. So that's what available here. So here again some of the cases, covers, switch box, rubber, everything. Most of the time this failure of rubber seals lead to major accident, right? So you can see nitrate, bulletine, silicon, fluorine. These are the things. So I will tell one reason why these materials are important, or when I learned this requirement. See, one of our students, when he went to a company, Danfoss, in power electronics and drives, they asked the guy to develop a current sensing mechanism. Size should be very minimal. Size should be very minimal. They have to use shunt, not like what we are using for project like lens sensor, costliest one. Industries will never go for costly. They will always look for low cost but high performance. Then they are asking you choose a shunt. Shunt is a small resistance, like what we did in power electronics lab, 2 ohm shunt. We used to have a nichrome wire. Manganese, galvanol, these are the another wires which are being used for making resistor. The area required for Gantal wire, nickel wire, nichrome wire, manganese wire is different. But what happened, unfortunately, we failed in teaching Ohm's law, the impact of those materials on our Ohm's law experiment. Of course, we are completing Ohm's law experiment in 30 minutes and we are doing other work. No doubt about that. But there are huge, what should they, I can go for several questions in that. How to reduce the size of 380 ohm resistor to half? Or to 20% we want to reduce. How to do that? What kind of material? Rheostat made up of what material? So those kind of things should come out. So that's the thought processing asked in their R&D team. Made us to learn in everywhere, yes. Even if it is a limit source, there should be some different material. Application notes. I use this application note for these sessions from the industries only. And if you see, some standards are most important, particularly with respect to switching. These are the most important AC and DC. And also in operating voltage. This insulation voltage is most important. Most of the time we are teaching about the operating voltage, but we fail to inform about insulating voltage. Even you take wire or even you take switch, what we are using in our home. So what would be the maximum voltage that will be applied on those? Is there any number ratio with respect to applied voltage? Yes. So 600 volt. All single phase is capable of standing up to 600. Because sometimes there may be an impulse which will appear on our device. So for that impulse, our device should withstand. It should not get failure. And also for short circuit. If you want to select MCB, then we should learn about this short circuit things. Now, similarly for like pollution degree, already I told, IP40 means the is meant for your what kind of pollution, what kind of second one. There are two things. One is with respect to pollution degree 1, 2, 3, 4. No pollution, only light. Sometimes you can see it may be a snow, rain, or conductive dust. Dust, if you go to seal industry, there you will get a conductive dust. Foundry, you will get conductive dust. It is a pollution degree 4. Similarly, if you go for electric shock, class 0, class 1, class 2, class 3, particularly this class 0 to 3 is most important biomedical. Nowadays, lot of oxygenator everywhere. See, to my knowledge, even in Coimbatore, 5 to 6 companies, they have started to make an oxygen generator. Everywhere. Previously, it was a ventilator with the pump and those things. So now, see, there should not be a milliampere leakage current in those equipments, because it leads to a lot of issues in biomedical equipment to the human body. That's why it's most important. Then, particularly to the limit switch, we should know about how much it can pre-travel, what is operating point, because when I am pressing that, till some point the contacts will not get open. Further, if you push, then only the contact will close. So, particularly when you go for high fast logic system, you take example of elevator used in airport. So it will move fast. Whenever a human comes or somebody plays, then the speed will get reduced. So in those points, operating point, release point, over travel. So all these points are important. So what here we should know is there is some terminology available for limit switch, particular to its operation. So detail can be studied later because it will be more. So I will add this slide so it will be useful. Similarly, single pole, single double throw. Most of you might famous with this because we are using in regular. But how to represent those, that is most important. Because drawing is important. We are sending a drawing to several places. Based on the drawing only, they will make connection. So if you put downwards, it is wrong. We have to put it in downward because the plunger is moving like this. So when a plunger moving like this, the brush will come here. The brush will come here. So it should move here and touch. If you look here, when I give a brush, what will happen? It's a wrong. So it will move like this. Similarly, the load one side, load to one side, it should not be connected like that. So every load should be connected on one side because there should be some common. One side plus another side negative. So if you do both, then there may be a common ground problem will occur. Then of course, it's IP protection. First one is for solid bodies. Then second one is for your water bodies. Suppose mostly IP57. 5 means just protected. Protection against the effect of immersion, IP57. Suppose when you keep your machine in the atmosphere, IP57 is enough. Sometimes people will go for IP60, 65, 67 like that. So, but this number important. Then you can see the applications where those kind of limit switches are used in material handling. It is a plunger line moving. Here is one kind of machine tool application. This is also another kind of machine tool in palletizer. It is fixed in the top. And it is used for filling silo, tank. So this is about the basic mechanical limit switch. Bureau is a keyword used by Siemens, then followed by several industries. So what is Bureau? Basically, Bureau is a sensor used for inductive, capacitance, ultrasonic, photoelectric. So all these are combined together and it is called as Bureau trade name. But how to select? If you want to choose any inductive, capacitive, ultrasonic transducers, what you want to look? First, you should look at the requirements. Then you need to check for what kind of input and what it should do, its duty, whether it is a heavy duty, light duty, and what is going to be your environmental condition. Will it be water splash protection or dust protection or fire protection or chemical protection or gas protection, like that? Then it should go for what should be the sensing range, whether it is a wide range or short range. Are you looking only the short range with the good precision and resolution accuracy, or wide range you are looking? And Namur is another international Germany standard that are being used by people in very critical applications, like your military standard, equivalent to mil standard, like flight. Failure should be 0. If we forget to avoid those failure, double protection, then what will happen? You know that it would be a huge, huge damage. Then whether it should be a pressure proof or any kind of reduction factors to be implemented. See, this reduction factor plays an important role in that. I could say that example, sometimes 2-3 sensors will be placed. The ultrasonic wave or some kind of infrared sensors, IR wave, or some kinds of radar that may cross some small values of physical quantity from the sensor, may cross. It should not affect. So how we are going to reduce those things? The next one is interface mechanism. Nowadays, there is a bus. Nobody wants to use a wire. Everybody should be in network. That's why people are going for actuator sensor interface like CAN-based, Modbus, Profibus, Profinet, EtherCAT. Now, EtherCAT from Beckhoff Industry is the fastest networking interfacing technology available in the world. When 5G comes, and it's going to be almost real time. From sitting in Coimbatore, I can do complete control of machine in another area, maybe Europe, but without much delay. Maybe a Robinson satellite loop to satellite and then receiving. That one loop time would be a very, very fraction of microsecond. By the time the EtherCAT, even now EtherCAT is being used in a lot of places. Then according to the media, like gas, liquids, flammable dust, ignitable fibers, it is classified as class and group, class 1, class 2, class 3. And what kind of chemical? This acetylone, hydrogen, ethylene. See, you take a lot of places, ethylene and methanol, gasoline, propane, even in biomedical industries, hospitals, and this metallic carbon grain dust, purely for industry. So most of the medical equipments fall on this class 1 category. So we have to check this category most important. Now let us go for of proximities or limit switch applications. So this is the metal. You can see a reinforced application. This is an application. You can see below. It's being used. Live, you can see 10 million operations. So these levers can be adjustable with respect to a carriage boxes thickness. It should be easily flexibly adjusted. Sometimes you can replace this and you can put, or you can change the orientation and you can adjust. So these things are mostly interesting. And if you take a CNC machine, this kind of mechanism for door lock, and similarly a conveyor or any AGVs, People are using this type with the extension of this cable. It should go both sides, right? Whether it's go up or down, you can see during up it should not get disturbed, only during down. And some kind of paper feeding, steel, rolling mill, everywhere it's kind of needle and with the spring valve. And this is another operation. It will move downwards with the roller. So these are some of the applications of the unit switches. So similarly here we can go for understanding proximity. So far we discussed about mechanical, but when you come to proximity with ultrasonic, inductive, capacitive, non-contact type. So here you can see that it is a sensor which can be detected without physical touch. So one is by inductive nature, another is by capacitive principle. So both inductive and capacitive proximity sensors are widely used in the industries. So it will be look like this basically. You can see it may be a DC inductive proximity, and you can see there are some specifications that like M8, thing like you can see M18. So mostly this M18 is a thread size where you are going to fix this. The length, and M is a standard used for representing the size, and it may be a PNP or NPN in nature, depends upon the nature of output. It may be a logic 0 or logic 1. So this is proximity with the wires. So 3 wires mostly. One is this color code is a standard. So what you are seeing here, for example, here you can see brown, black, blue. The color coding is important, plus, minus, and output. So, for example, brown, black supply, then this blue is going to output. So, this output will be connected to our controllers. So, this is one thing. And here you can learn about what distance it can sense, like it can sense up to 8 mm, and the operating voltage, maximum, minimum, and how much linearly you can give a distance to connecting. So these are the important thing. So how it functions shortly, when metal object kept in front of this sensor. Sensor is basically made with some coil internally with a high frequency generator. Nowadays, a small inverter is being designed. I want to tell one thing. These ICs, roughly around 40 cent. Even my colleagues, classmates, one or two guys manufacturing this proximity in a big level. So they are getting this IC from Europe, and they are making the coil and all other things like this coil and encapsulation in the front portions, complete shielding, here and they are sending out. So it is only 40 cent IC, which is generating a high frequency that is connected to a coil. When a high frequency current passing through this coil, it will emit a flux. So that flux going and touching the object in front of that leads to changing its output like this. When the wave comes and touches, immediately the self-inductance value will change. That's why it is inductive nature. Sometimes it is capacitive. Because both inductance and capacitance, if you want to calculate inductance, the distance will come. If you want to calculate capacitance, the distance will come. So it acts as a dielectric. So when the object comes and go out, its dielectric medium changes. So non-conductive, people want to go for capacitive, and conducting, they want to go for inductive. Now, there are different versions available. Let we will see there are 3-wire and 4-wire connections. I will tell what is what. If you take, it may be NPN or PNP. 3-wire means plus minus. So one is directly go to blue or supply, black is output. But this plus is going to be a common for sensor as well as for the load. Sometimes in PNP, center point negative, right? Output is going to be in this is going to be negative. So minus is connected here, so the output will come plus. Here output is going to be common point, plus is connected permanently, like this. In 4-wire sensors, you can see plus and minus different, but you have both normally open and normally closed contact. So here you have only one contact. Here you have NO as well as NC contacts. So depends upon the requirement, you can go for either 2-wire or for 4-wire. So this is about the proximity. Next sensor, people are looking for ultrasonic. So ultrasonic sensor compared to proximity, it is still quicker, response time is faster, high frequency. That's the reason why we are going for here. Before that, what is your ultrasonic wave? So low frequency is above this value. All are called above 15 kilohertz. Starting from, but there will be some small, what could say, some noise will be there, but 25 kilohertz and above, it will be a completely comfortable ultrasonic range, and people will use this ultrasonic. Basically, it is a horn type nature. The horn, what we are using, you could notice, when you give an electric signal, there will be a vibration. That vibration makes sound. But that vibration, sound waveform is in audible range, hearable range. That's why we are able to hear. That is a horn. If you vibrate the plate above some 25 kilohertz, then the sound generated by those plate will not be in a range of hearing. That's it's going to be ultrasonic. Next picture is shown. Here you can see horn, is electric, those things, right? So here, let us will see some of the sensor. IFM is another company where you will learn a lot of things. See here, you can see orientation. This is one kind of ultrasonic sensor. Here, one color is transmitting, another is reflecting. This is another type. So different variety of ultrasonic sensors are used to detect different applications. So here you can see no reflection, but as soon as it touches green color wave going. Similarly, this filling. Sometimes it may be a transparent object or maybe a difficult in shape like this, or it may be a different color. So how we are going to differentiate those things with a sensor? We want to do it independent of orientation, independent of size. Sometimes it may be a sound observing objects. Sometimes continuously we want to measure the distance, particularly in winding, paper roll mill, those things. Sometimes in a place like level, filling level, it may be a bigger or maybe a smaller tank, or it may be sometimes very big kind of dams or silos. By the time, different type of proximity sensors, people will change. So that's a difference. Sometimes they will put some kind of filter like this with respect to existing one. You can notice. Now, when the volume changes, they will change the wide bandwidth of ultrasonic wave. So these are some of the ultrasonic sensors variety you can see used in the industries. Maximum up to 8 meter. So proximity switches cannot be go up to 8 meter. Only ultrasonic can go up to 8 meter. Again, I think already we checked those things, different effects, and ultrasonic proximity is even also classified as ultrasonic proximity, ultrasonic retroreflective, ultrasonic through beam, distance measuring ultrasonic. All are basically ultrasonic, but proximities just act as a switch. Retroreflective will be glassy nature. Through beam sensor like bottle filling, and like kind of level sensor and distance measuring, and sometimes uneven surface where you will get a lot of reflected waveforms. There, with the help of filter, they will capture that exact things. So these are the things. Just you can have a look on this application. It is a level measurement, what we discussed. These are some ranges called compact range, then through range like this. This kind of anti-collision may be there, right? In automatic railing mechanism in the mines, collision should not be made when it moves in a different orientation. Then you can see small bottles. Third application, height sensing. So these are some of the important critical application people are looking for ultrasound. Sometimes quality rejection of piece if the dimension is not within a limit. We know that a lot of image processing is going on, right? People are expecting cameras. But nowadays, even with this reflective distance, very accurate measurements are being done. Sizing can also be done. So there's no need of additional camera for things. Sometimes they will go for, is there any breakage? Suppose you take this kind of mat. This mat may be a paper roll, or it may be a cloth, or it may be any kind of plastic or leather, any application, steel rolling mill. They will do it this for any breakage or any dimension variation. Inspection purpose. Then is again another measurement. Contour recognition is most important. Pupil sensing, safety mechanism. Sometimes they will go for whether this loop is correct or not, particularly in seeing machines, even in mask manufacturing. It is a one example we are doing nowadays. So a bunch of mask manufacturing, there will be some bending things. By the time they will check whether the loop is running correctly or not. Wire and rope and diameter sensing is another important thing. Sensing of diameter in lamination roll or in 0.2 mm, 0.6 mm, 1.2 mm seat thickness when you are rolling, whether it is coming correctly, they will do this. Bottle count. Here they are using a through bead sensor, right? Bottle count, whether the bottle is filled correctly or not. Now you know that this kind of cleaning of vehicle sensing, positioning, several applications, ultrasound is being used. So now let us see the mechanical, another sensor is a pressure switch. Pressure transducer and pressure switch. So we'll see one by one how the mechanical switch works. That there is a mechanical diaphragm. The physical quantity will appear up to this only. So high hydraulic pressure oil come up to this, and this compressible spring with a great material stiffness and spring of coefficient of spring. So this movement makes this plunger to move out or in. Accordingly, the micro switch in the top will get closed or open. So in most of the places, it is look like a cooker, what we are using, pressure cooker in our home. There we are using a weight, but here we are using a spring. All are with a great pressure compensating, leakage, small diaphragm washes, which makes the switch to work comfortable. So this is a pressure switch, you can notice here. So when a press inlet comes, this diaphragm moves up, down according to the pressure changes, so that this will function. And this is going to press this. So here you will get normally open, normally closed contact will get or close. See, in industries, these are the industries where the pressure switches are extremely being used. All are big oil and gas industries. power plants. Several places people are using this. So this is another view of pressure switch, dismantled view. Whatever we discussed there is available. And this is another called foot switch. People are using this foot switch in several places, including your CNC operating machines, CT scan machines. Even nowadays, if you go to a hospital like a dental hospital, doctor will operate with the foot switch and see operation theaters everywhere, right? This kind of foot switches are being used. So it has some NONC contact and with different type of termination with respect to current requirement and also standards. This is about foot switch, right? These sensors, so for some digital sensors we have seen, whether it may be a limit switch, proximity, ultrasound, pressure, laser, whatever it may be, we are going to connect it. So in connection, see, there is two things we have to look. One is on current sinking. Another is current source. What do you mean by sink and source? See, if you connect plus 24 volt as a common, then it is going to be a sink. Minus will be connected here. That may be a two-wire loop or it may be a fully isolated loop. What is two-wire loop means? For both sensor and the controller, they will use same power supply, 24 volt. You can see this point is common. See here, this power supply 24 volt is coming to common. Hope if I change my laser, then it will be easy for you. Plus 24 volt comes to control panel, and from this it goes to transmitter. Transmitter is nothing but your sensors. But here you can see it has separate power supply, isolated power supply. It has separate. So if you decided to give very precision accuracy sensors with a less noise, better to go with this. And a simple comparison is given here. Limit photoelectric, inductive, capacitive, ultrasonic. Advantages, disadvantages, and application. I think just reading would not be enough due to time constraint. You can go through in my. And some, yes, I want to mention this here. North American who is not following IEC standard. Internationally, IEC standard is a unique, but North America, Canada, they are following UL standard, underworth laboratory. Their representation of single pole, double pole switches will be like this. In international style, it will be look like this. Particularly, why we should tell to this to our students is when they go to industries. Nowadays, most of the industries, even you take L&T, they are providing a solution. They are not manufacturing. Sometimes they are technology solutions. So when you make a design for America, then your schematic should be like this. When you make same design, same machine for Europe countries or some other international countries who is following IEC, then it should be like this. So that's the reason why I want to say this. Then, of course, photoelectric sensors are in the range of from green LEDs beyond that, which is visible. It will be in the range of 750 nanometer. To that, photoelectric sensors are being used. Different type of photoelectric sensor like diffuse with the background suppression, retroflecting, and for through beam, color sensor, color mark sensor, slot sensor. So these sensors are categorized not based on fundamental principle. It is based upon only application requirement. So, for example, verifying objects in clear bottle. Another thing, flow of pallets carrying bottles, whether it is available or not. So opposite side, through beam, right? counting cans. Can may be reflecting in nature. Here we want to cross the carton box. So carton box is different, tin can is different, bottle is different. Even in bottle, different colors, filling mediums is different. Similarly, sometimes we want to read only some marking. Sometimes you can see that parking we need to control, or sometimes some mark which indicates the end of road. So these are the some applications needs different category of photoelectric sensor. Right. This is about digital. Now let us will come to the another part. It is called analog sensor. So we know that why analog. As I said, in process industry, continuous changing signal, we are looking for process analog. So that analog may be 3-wire analog sensor where plus supply and minus supply is common for transmitter, common for sensor and controller. Advantage, minimum iris requirement, but disadvantage, electrical interferences will be picked up. Some small noise generated in any form in the sensing area domain will be picked up. So sensitivity is going to be poor. Then another one is a 3-wire but little isolated. So how it is little isolated, you can see here. So plus 24 and minus 24 is going, but the minus is not connected here. For the controller, it is separate ground. Again, it is okay, but not for some spurious signal. Spurious signals means even you could hear when telephone comes, when you talk over by landline, some pat sound will come. When you keep your mobile phone near any electronic display gadgets, then display will get struggle little. How it comes? Because of spurious. It may be due to harmonics also. When you want to filter that, then definitely we should go for 4-wire analog system. So any analog sensor, it may be a pressure, flow, temperature, anything. There are 2-wire, 3-wire, 4-wire. You can't use 4-wire in all the places because it is costly. You need a separate power supply for transmitter, separate power supply for controller. All depends upon the application. If it is a sensitive, then you should go for 4, otherwise you stop with 2 or 3. So in 4 isolated, you can notice it has separated power supply. This controller has separated power supply. This controller may be your microcontroller, microprocessor or PLC, anything else. Right? So it may be, for example, this application video will make you do more. Here you can see most of the analog sensors are basically based on displacement. Here you take a pressure transducer. It is a PLC to which all the sensors are connected. But you can see the pressure unit connected in the outlet, at the input side, and in the bottom. So pressure units are basically with the Pascal or bar or PSI. When you go out to the petrol station and you want to put your car tire pressure, air compressor, bar, 32 bar. If you open your car gate and if you see that how much it should be filled in this, you can notice. What kind of pressure transducer that we are going to use, whether it is absolute or differential or different varieties. But in all the cases, whenever the pressure makes the movement of this diaphragm will convert your physical quantity into either 4 to 20 milliampere or 0 to 10 volt. Now, as I said earlier, why do we need a 4 to 20 or 0 to 10? let us, before going into the different category, if there is no deduction, 0 volt means no issue. But if you put a 0 current, whether 0 current is because of open the circuit, break the circuit, or sensing. That's why instead of 0 in current, they are putting 4 milliampere. One more thing I want to tell, why current input is being recommended nowadays. See, now distributed control system is coming up in a big way in the industrial automation. Very big power plant, very big industry. Sensors are placed in different locations. From that sensor, the wire should come to the controller room, centralized room. It may be sometimes in a petroleum refineries, cement industries, steel rolling industries, the centralized controller room may be nearly 1 kilometer apart, minimum 0.5 kilometer. If you run the wire for 0.5 kilometer, then you know that for sensor, because of current nature, we will use a small wire. So that small wire area, small means resistance high. So the drop will be more. How we are going to compensate the drop of sensor signal? Ohm's law. That's why I said, now they are applying Ohm's law. Now they find why if you go current in a series circuit, wherever you measure the current, same value. So no drop. That's why we want to go for current sensor as analog code. So now you can see there are 3 types of pressure transducer. Gauge pressure. What do you mean by gauge pressure? If you take tank, any pressure with respect to atmospheric pressure. Basically, atmospheric pressure is 14.7 PSA or 1 bar. We will say atmosphere is 1 bar. So with respect to atmosphere, if it is greater than 14.7 or 1 bar, it is called positive or negative. The next one is absolute pressure. Absolute pressure is always with respect to vacuum, that is 0 psi, 0 bar. But naturally in atmosphere it is 1 bar. So if you measure the bar in a completely closed container with a vacuum in the top, that is called absolute pressure. But if you measure any pressure with respect to a atmosphere, open to atmosphere, that is your gauge pressure, then you will go for the next one, differential pressure. So with respect to the one side and with respect to another side, people will check this. So probably this is your air, which have a very less value. Here in the bottom, you will have a high density like this. In the bottom, you will have a density. In the top, you will have only evaporation. So when you compare both the things together, then it is going to be differential pressure. In sometimes where people are using a filter like this, they will put a differential pressure here, transducer. See, it is this kind of thing is being used in your building automation and in a lot of filtration tanks, industries, compressors, air conditions, centralized air conditions, cooler, chiller, refrigeration, heat ventilation, air conditioning, cold room storage, several places. See, here the pressure is more, but when some dust or occupied this filter, this side pressure is going to less. So this differential pressure, comparing this and this, always it shows difference. When this difference goes beyond certain limit, then automatically it will indicate, yes, there is a choke in the filter which is to be cleaned. Lot of blowers. Blower means you don't think that blower which we are using in home. The blowers which are used in cement industries and in very big floor mills and big undergrounds, tunnels, where they need a huge oxygen from outside air, they will pump out. Even in big oxygenator machines, the air will be chucked from the atmosphere and then it will do a lot of filtration. Then it will go for several processes, condensed gas, those things. So that the filtrations to be automatically monitored, that is possible with the help of this differential gauge pressure. So when it completely choked, then you can notice this side is 34 and this side is 24. It indicates clogged filter, which can be easily determined by this type. So Kaj and different, even people will use differential here. It is a light air, it is a dense water. So it has two different things. When the water filled up here, this pressure will go upon increase. So you can calibrate, yes, the tank is full or open by using this also. So this is about three kind of things, right? So pressure, flow, everything operates in this principle. The next one is thermo. In 1821, several, almost, I think 200 years before, Thomas Seebeck discovered that two different metals when joined, and when you create temperature at both ends with the different, and it will generate some electron motion. That movement of electron is fixed as a current. So this phenomena is basically called as Seebeck effect, which reflect on the name of Thomas Seebeck. Now thermocouples are made using this Seebeck effect. But all these thermocouples are not determined by this time. Thermocouples are keep on upgraded. How? Because of the metallurgist technology. See, thermocouples are classified B type, E type, J type, K type, N type, R type, like this. Different types. Different type of material composition. Platinum, rhodium, nickel, chromium, alloy, and iron and constant, nickel, chromium alloy, and nickel, aluminum alloy. Nitrosyl is another alloy, or nisyl is another alloy. Platinum 13% with rhodium and platinum. Copper and constant. You can see here temperature range. It varies from minus 59 to plus 1700. So you can see the thermocouple versus EMF of different classification. So one uniqueness you can see, whether it is a B type or it is a E type, all are giving a millivolt out. Either it may be around 10 plus or it may be 70 plus, less than 1 volt. But this millivolt should be amplified well to connect into a circuit. So these thermocouples are most useful in lot of industries. Next, we will go to level sensor. You can see here, it's a point level measurement or continuous level measurement. Point level means low height. Continuous means full depth. How much tank is filled now? How much volume of liters filled? All those things. And you can see the type of the things. You can notice here the type. What kind of technologies that you can use? Capacitance, optical, conductivity, vibrating tuning fork, float switch. So these are the different sensors types that's being used for level measurement. Ultrasonic and radar both are used for continuous measurement. Mostly ultrasonic are used. Radars are used in big silos, particularly in very higher end mechanism like chemical industries, fertilizer based. In capacitance level sensors, whenever this liquid varies, the dielectric medium varies, so the output will be farad. But that farad will be changed in terms of reactance then to voltage and current. Advantage is very small, cost accurate thing. But the thing is invasive. You can't put this inside. And calibration is required at several places. But this could be used like application here. So whenever that flow detects, it will send a signal to turn. Next is optical level sensor, where the pyramid kind of structure is provided. If there is a liquid, then it will get reflected. Otherwise, it will get refracted. And photo IR waves are passing through this. based upon the availability of the liquid, the reflection diffraction changes, thereby the sensors ICs put inside will detect. But disadvantage is if some dust accumulated, then it is going to be a problem. Next one is very low cost, the resistance type. See, low level, when it gets filled and when it touches the top electrode, then the conductivity will make. It acts as a switches. So the conductivity resistance changes in this is being calibrated in the controller. So thereby the distance or the level or the fluid quantity can be indirectly calibrated. So it's also having more parts and cost is less, very easy to use. But again, it is not an, it is an invasive and only it is useful for conductive liquid. But the probe will get eroded in a few years or days. But it can be used for anything. This is another interesting one. It's a tuning fork. It is kind of vibration. A special alloy made whenever that liquid changing its medium, then it will start to vibrate. That vibration frequency will be used for detecting this level. So again, it has some issues in the fine-tuning calibration. So in few applications, wherever the things are keep on changing, the quantity keep on changing, then only you will get some vibration. Those places it is being used. The next one is simple float, just the mechanism which is used even in our toilet flush tank. So when the water comes up, we close the switch here. But in our flush tank, the valve is closed. Here, the electrical contact is being released. So again, this point. So all these sensors are being used as a switches. Now let us come to this analog quantity. It is ultrasonic wave transmitted traveling in the air at same velocity. When it touches the medium of water, liquid, and it will get penetrate and refraction. Reflected waveform will again come and touch this receiver and it will generate an electric voltage. That is your ultrasonic level sensor. This ultrasonic level sensor is widely used in detection of length, depth of the tank, all those things. This is another microwave sensor where you are looking for high precision. Suppose milliliter composition will make a lot of change in liquid medical or some in bioprocessing. Very, very crucial things where people will use this radar. Even it can detect liquid, base, powder, and solid, and it has a lot of advantages. This is a kind of thing you can see, which will detect. All other things are point level, right? So ultrasonic flow using applications like this, just have a look that's being used. So it's a two sensors like this is being fixed and differential sensor. When the water flows, ultrasonic wave comes here and reflects, it goes here and it's detecting. This 0.4 liter. Now when this water flow increases, this reflected waveform will also travel with this water and it is changing. This is a differential thing. Reflective type. You can see how the ultrasonic this is being used. So this is not related to this, but just to have some idea. CAN switches are being used as a small sensing mechanism in different places. Just I want to tell how the cam sensors are looking. Here you can notice this white color, cam position changes. So just by changing the cam position, the switch inside will get close contact. Mostly this is used for selection application, even in medical equipment or in some other place, it is used for selection, low cost. Why I am using this? Sometimes people will go for solid state devices where it lead to lot of cost, but only for selection you can go with this. So some mechanical plunger arm you can connect like this, you can notice. So this movement and this point, hope this you could see here. This helps, right? Yes, this is about analog, but still there are a lot of sensors. So my sincere request is you can go to SICK, S-I-C-K, Turkey, Banner, at least this company's website and Honeywell. You can see lot of things. Now let us in next 10 to 15 minutes, we will quickly look on the health part, healthcare, enormous sensor. So I would like to summarize this like respiratory system. If you take ventilator, hot topic of present scenario, it is if you take one ventilator, we have a airflow sensor, barcode, basic and AML switches, humidity and temperature sensor, magnetic sensor, oxygen sensor, pressure sensor and transducer, temperature sensor. So many sensors are used in this ventilator. Similarly, oxygen concentrator, again this is in today's hot topic, airflow sensor, basic and AML switches, magnetic sensor, same kind of oxygen, pressure and this one. So if you see in medical system, healthcare system, in most of the cases, airflow, humidity, oxygen, pressure, SpO2 and temperature. And one more sensor is force. And sub-miniature load cell in infusion pump, people are using some load cells. And this is a patient monitoring system. So these are the major equipments where sensors are being used. But the technology, if you see what kind of technology is being used, you can see here, air bubble, force load, air bubble, force sensor or load cell, humidity, level sensor, piezo film or ceramic is used for measuring the various things. Position, press, pulse oximetry, temperature, then vibration. If you see these sensors will be used, enormous application. Catheter and balloon inflating pump, assisted baby delivery, blood pressure monitoring, body weight intensity, brain tumor, hypodermic needle probes, contrast dye infusion, dialysis machine, discrete vital sign monitoring, disposable blood pressure, drug pump, electronic stethoscope, heart rhythm monitoring, hospital bed, gas monitoring, infusion pump, kidney dialysis, myocardial needle probes, like this. I can read out all those things, but you can go through this when I share these slides, lot of things. For all these things, I want to tell something on this. Why we have to look this? See, as I said earlier, 30% of home is having oximeter, pulse meter. One thing, we should learn about history. people know about Nalanda University and Taxila University before separation of Hindus and Pakistan? See, this Muslim barriers, it is nothing related to religion. I am talking about history. It is not against one religion or community. I bold this point in my online teaching more. You please note it. It is not related to that, but it is a history. When you look the history of Taxila and Nalanda, lot of materials are being burnt by war, Muslim burden. Kajani Muhammad took a war 18 times, then 19th time he won. All histories we read, right? So that soldiers finally burnt lot of libraries in Taxila. Now Taxila is in Pakistan. Nalanda still we have revamped, but we lost lot of things. In that, one thing that I want to tell is Zivok, pulse being expert. Actually, this slide I copied from my son preparation, who made this preparation for his school assignment. Then only I learned who made a first pulse reading. Of course, he is a person he cued by Nadi Bronov. This pulse reading is done by India. The Sanskrit things should be converted to different regional languages. Those regional languages should be taught to our young kids. Those concepts should be converted into semiconductor physics programs, and that should come as a small instrument like pulse oximeter, electronic stethoscope, all those things. Like that, language grammar, for and for economic policy and statecraft, everything. If you take Chanakya, Vishnu Sharma, Charaka, Panini, everybody was in Nalanda and Dakshina. And one more thing that I want to point it out as a censor, in Tamilnadu, a district called Thapuram near Kundadam, one Vishnu temple, there are several images of baby inside the mother before birth. At the 30 days, at 70 days, at 90 days, up to 10th month before delivery. There is a sculpture, images made in this temple. What happened when a foreigner come and took photograph with $100? Our guys are well happy. Right? For us, it is only 20 rupees. For foreigners, it is $100 or $150. What they did, they took all these images into mesh analysis. Those mesh analysis images are being used as a reference for automatic scanning. Now people are, when our women want to check during their periods, whether how much child growth, they're saying expected date of delivery 6 months, growth is good. Where they took this reference, all gone from our guys, right? So why I want to say this is the complete these things are coming up from the things from us. Like for example, you take respiratory ventilator. See, this is a ventilator block diagram. See here, there oxygen entering either atmosphere or from cylinder. It goes to pressure transducer. After that, the regulator is being used. Then we are using airflow sensor. Then you can see several things like 10 sensors are being used in this block. Airflow, temperature, pressure, humidity, oxygen, magnetic. basic ML switch, pressure sensor. Say as a biomedical engineer or as a nominal engineer, still if you want to understand its characteristic, better you can go to the Honeywell website and select these data sheet. Ask our guys to read and submit 2-page assignment at least, or 2 slides. When they present this, we can also learn. Combinedly as a whole class, we can learn. The guy is also going to interest to see all these things. Some ideas will come to young mind. They will do a lot of innovations here. So just reading a fundamentals in the sensors book, that's all. How temperature sensor works. That is a 2-minute job. After that, we should invest more time where it is being used. Then we should ask them to take this data sheet. What specialty in that temperature sensor? What kind of material they are using? What resolution, accuracy? How it is being configured? How sensoric signals are being filtered? So those things we can do it from the application node. So this is ventilator. Then if you take respiratory, oxygen concentrator, right? See here. One is a such tank, normal air in, then you have a compressor. After that, we are making heat to avoid the moisture. This electronic control circuit changing the temperature and this pressure adjusting. Then again, it goes to such tank where your air is being completely stored. Then it goes to the different sections like molecular sieve, where it's being separated. Then finally, it's being come to the product tank of oxygen. So we can teach this at least in the applications unit of our topic. It need not to be advanced topics. See, there is nothing advanced topics. When we teach measurements and instrumentation in 3rd semester, 4th semester, our assignment should not belong to our Shahani book. It should always look to the industries working on those. That's why I put in first slide the industries that are involved in our current topic or in our topic. If I am talking about the motor, then I should look who are the great manufacturers of motor. If I am taking a microcontroller top subject, then I should think the microcontroller manufacturer in the world, top 10. Let's go to their website, understand their application, understand their concept, classification. If we give those things as an assignment to the students, then a lot of things will come up because we know that our students are very, very good. 60 students in our class, 60 young brain, 18, 22 age. We are almost above 40 or above 30, one brain. We have to feed to 70. Right, this is one thing. Then similarly, if you come to the another like infusion pump, see this infusion pump, you can see automatic according to the flow of any medicine or glucose, or we used to tell it is a glucose trip. So there is a small sensor. It's detect whether the flow is being adjusted or not. Sometimes people will open it heavily, which lead to a lot of damage in the body, other organs. So there is a small electronic unit which controls the flow of this liquid. Say, I want to tell one thing. Nowadays, there is a small machine for your insulin pump. Even you can Google it, insulin pump. You can see programmable insulin pump. Nowadays, when a guy put an injection for a diabetic patient, he should at least take 1 hour rest or 30 minutes rest. But depends upon the kind of food. Suppose I am going to marriage today, where I am going to take 2 sweets. Automatically, I can change the mode like in our induction cooker, milk, boil, food, like that. Here, in insulin pump, you can select function, celebrity. So that means what? I am eating 2 sweets now. Accordingly, you adjust the insulin. So this insulin pump will slowly add insulin. So not one at a time. If it is made by syringe, then you will put an injection. Some say 5 ml or 6 ml of injection will be loaded in 2 seconds or 3 seconds. But if the 5 ml of insulin is happened for whole day slowly, then lot of side effects will be minimized. So that kind of insulin pump with a cost of 90,000 is being now introduced in market. Why can't we manufacture? The problem is the deepest knowledge. So our guys are capable. Only thing we should nurture is how to learn, how to think. When we made this, definitely they can do wonders. Similarly, in blood sample, you can see here sample holder, magnetic sensors is being used for blood and salivia analyzer. So sensor and pump, temperature controls, lot of things being used. So it is a Honeywell application note, right? So I took it from the sensors and switch solution for medical application. So I gone through this. Then some good readers always used to tell, first you take this application note. Now you will get some keyword. Say like for example, feedback to the control the flow of the test fluids. Now use this keyword and again you search to get good application note. How to control the or how the tests are done in fluids. It is going to be a separate thing. So once if you get application note like this, some keywords like this, so putting these keywords and again you search with the different things, then we will keep into learning. This is the kind of process how to improve the learning. So this is like flow cytometry block diagram, how the things being come inside, then completely it's being processed. Then it go to this. See how the specimens are being separated and samples are being specified. But the sensors will be very smaller in size. That's what I told. And if you take, these are the different Honeywell sensors used for different applications in medical. It will be a few mm. The size should be very minimum, and weight is also going to be very small. So I think just you can go through this. That's all from my side. Thank you for patiently hearing. Of course, you are being muted, so there is no interaction. I'm happy to clarify anything. So my session is up to level 30. So now the things is up to you.
Thank you, sir. Dear participants, do you have any clarification? Please post the question on your chat box or click the right hands option button.
Thank you, Anupama ma'am.
Sir,
Yes.
in participant side, one more clarification.
Yes. Yes, madam.
1 minute. Sir. Participants, I unmute all your mic. Please unmute once again your side and ask the question.
Or even sometimes chat. I am looking chat box. If anything there, I. Sorry, I could not hear.
1 minute, sir. 1 minute. Sir, you gave the explanation about ultrasonic sensor and capacitive proximity sensor.
Okay.
Capacitive. Told one 8 meter that is ultrasonic sensor used. We can range up to 8 meter.
Yes.
What's the maximum range of the sensor we have to use in this type of application? 8 meters is a small one, no? Small range of application.
No, 8 meter is 24 feet. You imagine you want to detect some object in the 8-meter distance. See, if you want to transmit ultrasonic wave beyond 8 meter, then the power consumption would be very high. So most of the instrumentation are not designed for handling higher thing. Suppose if you want to sense very rare applications, yes, there are some power amplifier circuit, cascaded sensors can be used in those points. But 8 meter in sensing is not a small distance. It is, compared to industry standard, it is enough. And in capacitive, yes, madam, in capacitive, probably capacitive, inductive are not suitable beyond, say, something around 12 centimeter or 15 centimeter maximum. So those are for very close sense. That's why it is called proximity. When you want to detect from larger distance, either you should go for laser. Suppose if you are looking, as madam said, some 30 meter, 40 meter, then you can go for laser. Laser with the more power. Yes, you can detect it. That is also possible. I said 8 meter with respect to ultrasound.
Yes,
but
sir.
for laser, you can go with a higher distance.
But cost wise, it be high, no? Laser is high compared to sensor.
See, in some application, cost is not an issue, but requirement meeting is most important.
Yes. I don't know these concepts, but now only I know. Thank you.
But in light plant steel rolling mill, where hot rolled steel is rolling, there, as you said, we can't stand in front of them. If any spark come out of that, then it will make puncture in our body. So that people are not allowed it. That laser sensor is used for preventing the dangerous zone from human being.
Good morning, sir.
Yes, ma'am.
Sir, I have a small clarification.
Yes, yes.
As you gave the insight about these sensors in industrial domain and at the same time in the medical domain, suppose we want to make the third year or the final year student to work on these sensing application, especially in healthcare. So, like, how do we can start? We have to start with the basic sensors, or first to know the principle behind these sensors, how they work, and then try to implement some devices or some application we can come up.
Absolutely, madam. First, what we can ask, let us you take oxygen generators, right? So in oxygen generators, first you should understand the application, how it functions. Air, how the air takes out in, why the air is being preheated, for what purpose. After preheating, why do we need a compressor? After that, why do we need sieves to separate oxygen, how it is being done? So if we understand the function, then for each function, the unit of measurement, like if you are heating means temperature. So temperature means what is the range, whether what kind of temperature sensor is applicable there. Can I put sensor directly or remote or RTD or thermocouple, active or passive? So those kind of questions should be raised. So once if we teach to the students how to ask a question for individual topic, individual block, from each question he will get an answer. According to that answer, he will go for another learning. So this is how the things are happening.
Oh, okay, sir. Thank you, sir.
Once he did that, then you can split into 2-3 batches. One batch will do this, another batch will do this. So then you can do integration over all the things. So system engineering also he can learn.
Okay. Okay, sir. Thank you so much, sir.
Okay.
Participant side, any clarification? Please unmute your mic and ask the question if you have any doubts. Okay, sir. Shall we conclude the session, sir? Sir, okay.
Is there
Ma'am,
any
please
harmful
loud
effects
your voice. Ma'am,
Yes, ma'am. 1 minute.
please
Yeah.
maximize your voice.
Yes, I could hear.
Is there
I could hear.
Yeah. Is there any harmonic sensors? Sir? Because those are also.
No, madam.
No.
No, the thing is, ultrasonic waves are not going to touch with our body continuously. It is very occasionally. Frequency of crossing the ultrasonic beam or touching the ultrasonic beam in our body is very rare. So, side effect would not be a very harmful or impactable, negligible.
Okay. Are we particular of these also, sir? Because the frequency, okay, that is ultrasonic waves. But are we particularly aware of even the amplitudes of these kind of waves?
Yes, madam. Depends upon the sensor physical quantity. The frequency will be variable. But output of ultrasonic sensor will be always either output or voltage or current output, like 0 to 10 volt or 0 to 5 volt or 4 to 20 milliampere. But the physical quantity, what we are going to measure, that decides the frequency range.
Okay, sir. Okay. Thank you, sir.
Okay.
Sir, shall we conclude the session, sir?
Yes, madam. Thank you. If nothing, then
1 minute. Okay, sir. On behalf of our PSR management, heartfelt thanks to our beloved resource person, Dr. M.Sundaram, Associate Professor, PhD College of Technology. Despite of his busy schedule, he found a time to share his excellent knowledge in types of sensors used in electromagnetic field, electrostatic field technology, limit switching terminology, working of capacitive proximity sensor, and he gave well explanation about in which application we have to use ultrasonic sensors and operation of mechanical pressure sensor. And also he gave wonderful information about how Chanakya, Vishnu Sarma, Saraga and Rani were used the sensor technology in ancient times. Very informative and technical session, sir. Thank you, sir.
Thank you, madam. I wish you all the best and hope everybody will be safe and we will cross this pandemic situation. Yes, thank you. God bless you.
Thank you, sir. Yes, sir. Also be safe, sir.
Thank you. Thank you. Bye.
Bye, sir. Dear participant, we will start the next session at 11:50 a.m. Thank you.